First of all, I would like to thank the organizers for a nice invitation to participate on 51st Annual Iran Mathematics Conference, and many thanks to Professor Ali Reza Ashrafi for its invitation. Today we will talk about Birkhoff zones, and this dynamical behavior is very important in mathematics, in different area of mathematics. Our work entitled on the behavior of Birkhoff sums generated by rational rotation. This work joined with Professor Anatol Borisovich Antonevich from Belarusian State University and Professor Andrei Kojerin from Moscow State University. This is our outline, and actually, I can say that dynamical systems started at the very beginning of human history by Babylonian and the Egyptians and others because they needed to understand the behavior of some elements in nature, but termed by dynamical system or named by dynamical system. I could find that was first by George Birkhoff, and this book is the first book named by dynamical system. Today we consider topological dynamical system. So we have a topological space and continuous map, and this map generates cascade dynamical systems such as this guy. And for any phi from x to r and n belongs to z, the Birkhoff sums is given by this formula. I mean, by this guy for positive n and this guy for negatives n. And by phi capital, we denote the maximum of Birkhoff sums. Actually, a lot of mathematicians studied dynamical system, and I mean studied Birkhoff sums in dynamical system and operator theory. Fuhrman, Hardy, Arnold, Hanin, Saini, Katok, and others, and this is a very important object. Let's here say that T is a linear bounded operator, and in Banach space, and the analytic function R is defined on resolvent set. We called it resolvent operator. So this guy is the resolvent operator. One more fact that if T and the same personalities, with the same personalities, I say linear bound operator, is a power bounded if there exists a constant such that the norm of the powers hold this estimate. We may define here, we may use here T to define weighted shift operator. And in next slides, we will consider T as a weighted shift operator generated by rotation. I mean this one, because we replace this shift, I mean replace the shift from x to x plus h to rotation of angle to ph on the unit circle, and we redefine here the shift operator and weighted shift operator. Let me mention something. So in short, I will say operator 2, and I mean by this weighted shift operator generated by rotation. So I'm not going to repeat and bother you by these long words, and just say operator 2. And very important to see that this operator generated biased by ash. This ash a very important part here. So we need it. Actually, norm of powers of operator 2 is given by a maximum of this guy. So product of absolute value of ax plus ash, I mean j plus ash. And in 73, Anatol Borisovich said that if H is a rational number, so the spectrum of operator T is is belong to this set, and if the ash is irrational number, then the spectrum belongs to this geometric average, which average of function A. I mean geometric average of function A. So and formula 3 shows that the spectrum should be included in such a ring, and the spectral radius is equal exactly to phi of A. If the spectral radius in 3 is equal to 1, so if it is equal to 1, so it means that all this part is equal to 0, and the norm of powers of operator 2 is given by exponential phi and x, so exponential of Birkhoff sums. So norm of powers of operator t can be given by exponential Birkhoff sums. This is the very important relationship between these objects. In 2015, we obtained a result that if the ash is a rational number, then the norm of operator T of power, I mean the norm of powers of operator T is located by spectral radius, and spectral radius multiplied by such a constant. The convergence of Birkhoff sums related to a very nice equation named by homological. And homological equation is very important because it was cited in the fifth Hilbert problem when the sole solution of analytic functional equation are non-differential equations. And we know that all those problems were presented in the Second International Congress of Mathematicians in Paris about 120 years ago, and some of them still unsolved. Here we see Hilbert. Especially I like to present this paper. This paper included a very important result and coded proofs, and very heavy to be read. Because it was not simple. It took from me 1.5 years to understand what is written here. And one of the results, if phi of x belongs to the space of C2 over S1 is not to geometrical polynomial, then there exists a rational number which homological equation has no measurable solution. Now we are in the very important point and our main result. 2017, we obtained that for not geometrical polynomial phi at x, and let phi at x is not be geometrical polynomial, and it satisfies condition 4. So I mean spectral radius belongs to 1. For any sequence omega n satisfies that omega n over n approach to 0, there exists irrational numbers such that for some subsequence nj, the norm of powers of operator 2 holds a very fast growth of rate as exponential omega nj. And one can see this, and I mean one can satisfy this growth for Liouville number. I will pass this theorem and also this result because I have only 5 minutes now. So for a special case of a rational number and the special phi of x, we have that norm of operator 2 is power bounded, and also here we have a norm for is a power bounded. Here we have a very important question. So in this theorem, we obtained for any not-geometrical polynomial, there exists a rational number. So, thus, for any irrational number, there exists a continuous map such that the norm of operator 2 holds the same fast growth rate of the given by exponential, I mean exponential growth. So in 2019, we obtained by using Birkhoff sums, by considering Birkhoff sums, that yes, the answer is positive, and for any irrational number, there exists a continuous map such that the norm of powers operators hold the same fast growth of rate. Unfortunately, I don't have time to say something and explain the details about the proof, but you can see here some facts. An application, so we see here by 7, there's a relationship between norm of powers of operator, I mean here any arbitrary linear bounded operator, and the norm of the resolvent. So the question, how's the effect on the resolvent? How the norm, how the behavior of this guy affects on this guy? So in 53, Grace obtained this estimate. He said if the operator is power bounded and the spectrum belongs to unicyclical or equal, so the norm of the resolvent holds this guy, and Reed in 62 said if the spectrum is equal to only 1, then the resolvent holds this guy. 2017, we obtained more fast growth of resolvent only with the finite order and normal type. So again, I'm very sorry to not um, provide some information about the order and type of entire function, but we see here that the norm of the resolvent holds exponential growth if and only if the norm of powers of operator holds this guy, and here we see the relationship between the orders and types. Also, the norm of the resolvent holds power growth only if and only if the norm of powers of operators holds this guy. And we see here for special case that for operator 2, I mean weighted shift operator generated by rotation, if H is a rational number, then the norm of the resolvent is growing very fast as exponential for omega equal to omega and zeta equal to this guy, and the power growth for omega and g equal to this guy. Here are some references. Thank you very much, and please stay safe.